Identify the vertex, the focus, and the directrix of the parabola with the given equation, then sketch the graph of the parabola. So 15 looks like it's missing stuff, and it kind of is. And that's because what we want to see is what number should we be using for the 4p. And there is a number here, but it's a 1. So I start thinking, okay, y squared. Y squared means right and left opening. If that's positive, that means this is going to be a right opening parabola. So something like that. Now all I have to do is find all the good stuff. Well, all of that comes from the fact that this was 4px. 4p has to equal 1. So that means p is 1/4. Now there's no h and k with this. There's nothing attached to the x, nothing attached to the y. That tells me that this is going to be centered at 0, 0. So my vertex, which is kind of my center of my parabola, is at 0, 0. Center at 0, 0 has to wrap around the focus. So the focus is 1/4, which is right here. So that would be 1/4, 0. And then the directrix is the line behind it that says, don't go this way, go the other way. So that's going to be back here, again, another 1/4 of a unit. So that will be x equals negative 1/4. So, vertex, focus, directrix. Oh, well, I kind of already made a sketch of it anyway. But with this one, the 4p value being 1, and this happens a lot in this book, means you can only go half a unit away from the focus on either side. So this would actually be a very skinny little parabola. Maybe I'll widen it by having that be a 1 right there. Like so. And that's good enough for a sketch. We just wanted a sketch. And the sketch helps a lot with trying to visualize which way does this open, where should these points go. And that's the case with all conic sections. Like you said, we can make a sketch. Things will go a little bit easier. Any other ones that you want to talk about from home? Well, please make sure your name's on those and mix them up. Closer look at our little equations. So, I'm going to back up for just a second. All right. Here's the problem. This book really does things kind of upside down and backwards when it comes to parabolas. That's not what you're going to see if you look for the equation for a parabola. It's the only book I've ever seen that does that, and it really does make it more confusing because what they try to do is use fractions for everything, and most people are not comfortable with fractions. So this is our up and down opening parabola, and our only job, if we want to write an equation for this parabola, is to find how far is it from the vertex to the focus, and then to decide whether or not, if it's going down, we should put a negative or not. And if down, we need to put a negative. And then y squared equals 4px are for our right and left opening. But our job is the same as it was for up and down. We need to figure out how far it is from the focus to the vertex. And then ask ourselves, hey, if it's going left, I better throw a negative in front of that and have it. But that's as far as we got yesterday. Today what we're doing is we're saying, okay, these were all given vertices at the origin, 0, 0. What if it's not 0, 0 anymore? And in fact, we already know what's going to happen. And h is going to have to be attached to the x. And a k is going to have to be attached to the y. So if we're going to translate these and move that vertex, up and down is going to look like this, like I have it in the blue. If we're going to translate the right and left, the left will look like that. So, new stuff today, but not, because we've already dealt with h and k before, and it really is the same type of thing that we're going to be doing. Now, that's not what we're going to see in this box, because again, this book really likes using this. which, if we were to multiply both sides by 4c, they're really just replacing the p with the c value. But all the times that I have studied math over all of these years, this is the first book I've ever seen that doesn't use p as the value for parabolas from focus to the vertex. So let's just stick with what you're going to see next year. So with vertical parabolas, those are the ones that are going up and down. We're going to see x minus h squared equals 4p times y minus k. So cross that off. Cross that off. And probably cross these off so you don't get confused about that whole 1 over 4c. If we have a vertical parabola, x minus h squared equals 4p times y minus k. If we have a horizontal parabola, well then the x's and y's switch positions. So that'll be y minus k squared equals 4p times x minus h. But our job for these is just to figure out where's the new vertex. And then again, what is the distance from the vertex to the focus? And then we can write an equation for the parabola because h and k and p are the values that we have to substitute in for. Now they might give us the equation and we have to work backwards and find the graph. They might give us the equation and say, well, what are the focus, the directrix, vertex, all the good stuff that we have. So there's a lot left here for us to take a look at. But it's not going to be too bad. So let's go down. This says, what are the vertex, focus, and directrix of the parabola with this equation? So the first thing I do is I notice, hey, that's an x squared. So x squareds, those are up and down opening parabolas. And since it's a positive x squared, this one should open up. So if that's the case, I want to make that look like this. Because that will give me my h and k values, which are my vertex. And I'll be able to figure out what p is and go from there. All right. So, I don't see any parentheses squared up here at all. Oh, we have to make them that way. And that uses completing the square. So what we'll do is we'll say, all right, I'm starting with this. Y equals x squared minus 4x plus 8. That 8 is not a perfect square. It's not helping me where it is. I'm going to move it over to the other side. And I am going to complete the square so that I have a number that does work nice. Because what it's going to do is it's going to give me a perfect square trinomial that I can factor as a binomial square. But to do that, we have to remember that itsy bitsy little formula to the square. Does anybody remember the teeny formula to get that value right there? Tommy, is that you speaking? Yeah, your hand was impressed. I'm like, was that Tommy? That's good. You're really, really close. What did you say it was? In fact, you got it. This b over 2 squared. That's what it is. Ax squared plus bx plus c. It's b over 2 squared. Now, if we remember that, we're going to go over here and we're going to put CTS on those little lines you have on the side over there. And b over 2 squared. Just like so. And the couple people that have their Chromebooks open are going to close them and pay attention. So here's what we do. Ax squared plus bx. Okay, b is negative 4. So I have to take negative 4, divide it by 2, and then square it. Okay, that's negative 2 squared. That's 4. I want to put a 4 right there to make that a perfect square trinomial. But whenever we do one side of the equation, we have to do the other. So let's see what this looks like now. Y minus 8 plus 4 will be y minus 4. And now we have that perfect square trinomial. Okay, what do you square to get x squared? Oh, x. And what did I square to get that positive 4? Oh, that was a negative 2. Now that's looking like a parabola. So I go back up here here and I realize x minus h squared, cool, this is all by itself. And then I have y minus 4 over here. Wait a minute though, that should be in parentheses. But there's supposed to be a number in front of it, because that's what I need for my 4p. Is there a number in front of this? There is. There it is. So what that does is it tells me that 4p has to come out to 1. And I don't know why this book does this, but they love, you're going to see that 1/4 shows in your homework again and again and again. So 1/4 of a unit away from the vertex is where the focus is going to be. So, what did they want? Vertex, focus, directrix. Okay, well, I can find my vertex. I have my equation right here. My vertex is going to be HK, 2, 4. All right, 2, 1, 2, 3, 4. I'm going to put a V by that for vertex. My focus is something that my parabola has to wrap around. And right away we knew this opened up. So that means I have to go 1/4 of a unit up. And that's where my focus will be. Oh boy, this is going to be a tight squish. Right there is my focus. Now, I'm going to go over 2 to get to my focus. I go up 4, and then I have to go 1/4 more. So I'm going 4 and 1/4 units up, but we're going to want that as an improper fraction. So that'll be 17/4. So there's my little focus, 2 17/4. Now, I know this is going up, and I know it's skinny, and here's how I know it's skinny. Because the focus is so doggone close to the vertex. If that's going to be close like that, I'm going to get a really skinny parabola. And then they said, tell us where the directrix is. Well, it's equal but opposite to where the focus is. So that's going to be 1/4 of a unit downward. The line that says, don't go this way, go the other way. So it's y equals, but it's not 4. It's 1/4 below 4, which would be 3 3/4. Well, again, we change that into an improper fraction, and that would give us 15/4. So the directrix is the line y equals 15/4. Now, I'd like to tell you that the numbers are going to work out a lot better in the homework, but like I said, for some reason, this book just loves using a p-value of 1/4. There's a lot of them that are going to show up that way. So maybe they want us to deal a little bit with fractions this late in the year. You know, want us to see, hey, the math is going to get more complicated. Fractions are just a factor of life in pre-calculus. They just happen. So we just got to roll with the punches. That's what we do. Well, let's see if you can talk me through this one. So this one says, what are the vertex, focus, and directrix of the parabola with that equation? First things first. Is this one going to go right, left, up, down? Where's it going? How do we know it's up? X squared, and it's positive. So we've got another one here that's going to open up. So the x squared piece again, I'm going to need an x minus h squared equals 4p times y minus k. It's just like the last one over here. So what should we do first with that equation? Move the 18. Sounds like a good thing to try. Worked last time. And that sets us up to do what? Sweep the square. Find me the number that will make that happen. 16, everybody? 8 divided by 2 squared is 4 squared, which is 16. And what we do on one side, we have to do the other. Oops, that was a line. Minus 18. I got carried away with my minus. So this will be y minus 2 equals something squared. What's the something? X plus 4. We have the same problem we had last time. First of all, that y minus 2 is supposed to be in parentheses. And it's missing something out front. It is a 1. So 4p is 1, which means exactly, they just love that. We better figure out a vertex before we go anywhere else. Our equation is y minus 2 equals x plus 4 squared. So where is our vertex at? Negative 4, 2. Yes, be careful. Remember, HK, you're always looking for the x coordinate first. All right, negative 4, 2. 1, 2, 3, 4, 1, 2. Vertex. Whew. A long time ago, you told me which way this was going to open. Which way? Up. So, where do I go to get the focus? Up 1/4. All right, so it's still going to be negative 4. It's not going to be 2 anymore. It's going to be 2 1/4. 9/4. All right. Whole thing would look something like this because at the focal width, remember, if this is a 1 for 4p, that means we only get to go a half a unit to the left and a half a unit to the right. So that is another skinny little parabola right there. Last thing to do would be the directrix. Where does that go? Y equals 7/4. How'd you get 7/4, JT? Yeah, we're at 2. Go down a 4th. It's 1 3/4. 7/4 it is. Good job. There it is. So once we understand how all the pieces come together here, then these don't take so long. But sometimes we have to complete the square to make that happen. Let's see. This one says, which is an equation of a parabola with vertex 3, 7 and focus 5, 7? Yeah, this was multiple choice, but I don't like multiple choice, so we're going to do this by hand. Vertex at 3, 7. Focus at 5, 7. I better see what that does. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. That's my vertex. Focus at 5, 7. Well, that was a big help. That was huge. Which way does this open? To the right. It has to wrap around the focus. That's a huge help. So this is supposed to be y minus k squared equals 4p times x minus h, because we always use y squared for right and left opening. Okay. H and k are the vertex. They already gave us those. So it should be y minus what? Be careful. It's not the 3. It has to be the 7. And that's because we have to watch out for h and k to go with x and y. All right, so we've got y minus 7 squared equals, well, I think we know what p is.
Does the 70 be negative 7?
The formula itself already has negatives for both h and k in this one. So that means all we do is put in the h and k. If we have negatives for our coordinates for the vertex, then yes, it's going to become a plus. I think we know how far it is from the vertex to the focus. Yeah, it's 2. We see that right up here. It's 2 units. 4 times 2 is 8. What goes in the parentheses? X minus 3. Done. Done. Now this one, I do want to take this one a little bit farther. Here's why. It's the first time 4p isn't 1. We've got an 8 there. That's the focal width. So what that tells us is the 8 is the total distance, which means it's 4 units on either side of the focus. So if we go to the focus and we go 4 up and 4 down, we can get this thing graphed really quickly. nice little sketch right there. And we could certainly give them the directrix really fast too, because this was 2 units to the right. That directrix is 2 units back here at x equals 1. There it is. So I know there's going to be some graphing, not a lot, but some graphing. I wanted to make sure that you had an example of that on here as well. That's not too bad. All right. Let's try this one. Did everybody see how getting the visual right away really set up the whole thing? It's so helpful with conics to just draw the picture. What do you have? You know, and go with that. So this one has a vertex at 1, 4. And a focus at 1, 6. So what does that tell us? It opens up. So do we want the equation with x squared or with y squared? Absolutely. Well, I think we have everything we need. X minus what? What is P? Vertex of focus, 2 units. 4 times 2, 8. Last set of parentheses. And again, super easy to graph this because we set it open up. We've got a 4 p-value, that's focal width of 8. That means here's another one where we go 4 units, side to side. Nice look at it. And then remember, equal but opposite to the focus is the directrix. I like this. So those were a little wider because our 4p didn't end up being a 1 like it has been in the other ones. 43210. Our objective was to learn all this good stuff about parabolas, right? Equations and graph them. Where you at? Yeah, let's see a lot of 4s. So that's okay. A little practice. It'll be good. I still see a lot of 3s. So there you go. Even though you don't have to graph them, a sketch is always really, really helpful. Let me see if a lot of them say graph. 24 to 29 are sketch the parabola. Sketch the graph of the parabola. Same thing with 34 and 35. I think I'm just going to leave it up to you because really you could make some pretty basic sketches for these and they would be okay. But if you want graph paper, it's over there.